All right, ladies and gentlemen, welcome to our new chapter, chapter 10.1. We're done with what were we doing with solving systems, and we're back into something we've kind of started before, and we're going to add another little step to it. We've done factoring. Factoring was X marks the spot. X marks the spot comes back in chapter 10, rational expressions. But as well as factoring binomials and even single monomials like numbers 1 and 2. So I'll go in and cover some of the things that we've talked about already, and I'll show you how they apply to simplifying rational expressions. Your homework tonight is numbers 1 through 21, odds only. So I'll do at least numbers 1 through 7, and then the rest will be homework due at 11 p.m. tonight. So you have time after class to watch the video and finish the homework. All right. So what we're doing here, what is a rational expression? It's an expression, right? It's an expression because there's no equal sign here. It's not an equation. Number 1 is not an equation. It doesn't say equals and then, something else over here. This is an expression in that it's just numbers and symbols put together, numbers and operations, right? We have 32, times m divided by 40 m to the fourth. All right, what we're going to do is we're going to simplify. So we're going to take something like number 1, and we are going to simplify it using some of the rules we know with fractions and with factoring to make this expression simpler. All right, so with number 1, what we do here is, since there's no pluses or minuses, meaning there's no like operations going on in the numerator or the denominator, like is the case in number 3, these are actually quite simple. What we're going to do is we are going to first simplify the numbers in front of the variables, so 32 and 40, and then we're going to simplify the variables themselves, the m's. We have m to the first and we have m to the fourth. So let's start with just simplifying the numbers. This is just a basic fraction. It's 32 over 40. Okay, so let's simplify that. How can I simplify the fraction 32 over 40? If you have your multiplication tables, the little laminated tables, we'll be doing a little bit of simplifying fractions here. So if you want to get those out, you can use those to help you simplify. But if you don't have that, no worries. Look at your two numbers. What can I divide out of both 32 and 40? And that number is 8. I could divide an 8 out of both of those. That's classic simplifying a fraction. So 32 divided by 8 is 4, and 40 divided by 8 is 5. So 32 over 40 simplifies to 4/5, and that's the first part of number 1. We take the two numbers and we simplify. So that's going to be 4/5. Now the next part, and you can see I left a little space there, we have to deal with our m's. Okay, we have m to the first, and we have m to the fourth. So I'm going to write it over here. So we have m to the first on top, and we have 4 m's on the bottom. I'm going to write it like this. M times m times m times m. Okay, that is m to the fourth written out. M times m times m. M times m times m times m. 4 times is m to the fourth. Okay, how we can simplify this, if there's 1 on top and there's 4 on bottom, these two can cancel, and I'm left with no m's on top, so no m's on top, and I have 3 left on the bottom. So the answer, the final answer here is 4 over 5 with 3 m's left on the bottom. That's a 3, m to the third. It's just a little too much. M to the third, that's a little better. And there you go. 4 over 5, m to the third is your final answer. An easier way to deal with the variables is you could just think, all right, I have 4, the exponent 4 on the bottom, exponent 1 on top. Just subtract those, 4 minus 1, and then leave your answer in wherever the bigger number was. Since the bigger number 4 was on the bottom, 4 minus 1 is 3, so my answer is m to the 3 on the bottom. All right. Let's try number 2 here just to see another example of these. Okay, start with the numbers. 24 over 20. What could I divide out of both of those? In this case, I could divide a 4 All right, so that gives me a 6 on top and a 5 on the bottom. And now we have to deal with the r's. Okay, so get rid of that. So we have r to the 5th, r to the 4th. If you use my easier method from the last one, do 5 minus 4. 5 minus 4, that's 1. So I have 1 r, and which is bigger, 5 or 4? Well, the 5. So my 1 r that's left is going to go on top. And we're done. Boom. There it is. There's the first part. Okay. Now, let's go, and now I'm just going to jump to the odds now. Now, it gets a little trickier. Once we put in these pluses and minuses, so like here and here, it's going to get a little trickier. We're actually not going to use too much of what we did on those last examples. This is where we have to bring in factoring, and this is where we bring back X marks the spot. We have pluses, and number 7 is going to be one of our X marks the spot problems. All right, so let's start here. Anytime you see a plus or a minus here, okay, between numbers, creating terms, right? This is a binomial. I have 2 terms on top, the numerator, 2 terms on the bottom for the denominator. These pluses and minuses creating terms actually binds these terms together. So what I do and what I want you to do for any problem where we have binomials or trinomials, I want you to put the respective parts of the expression in parentheses. So b minus 2 in parentheses, 7b squared minus 14b in parentheses. Look at the next problem. Boom, 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 boom. The reason I'm doing this and the reason this is important is because these numbers, okay, are bonded together. In number 3, this b minus 2 is bonded together. I cannot just break apart b minus 2. Here's what I mean by that. Here's why this is different than numbers 1 and 2. I cannot simplify this b and this b squared. I cannot. Okay? We're going to have to take this one part of the expression at a time. We're going to see if we can simplify just the top or factor just the top, see if we can factor just the bottom, and then see if we can cancel anything out. As it stands right now, I cannot cancel or simplify anything from the way that number 3 looks. I cannot reduce the 2, negative 2, and the negative 14. The reason I can't is because they are bonded, okay, in these expressions. They're bonded by that plus or minus sign. B minus 2, I cannot break this apart. I cannot say this is a b and this is a negative 2 and then simplifies these two. I cannot do that. Okay, so that's why we put the parentheses in there so that we know that we cannot just break apart the numerator or the denominator in this case. So for number 3, what we have to do is we have to try and factor the top or the bottom of the fraction or both. Sometimes we have to factor both. For number 3, we only have to factor 1. If you notice, b minus 2, okay, you can't factor anything out of b minus 2, and I'll show you how to factor something out. We have done that before, but b minus 2 is just going to stand alone here. There's nothing, I can't divide anything out of b or negative 2 other than a 1, and I'm not going to do that. Okay, but I can factor something out of this bottom 7b squared minus 14b. Here's what I mean by factor out. So we take the expression 7b squared minus 14b. What can I divide out of both terms? Ooh, house party. Who wants to hang? What can we divide out of both 7b squared and negative 14b? We're factoring. And by factoring, I'm breaking down this expression, okay, into something that could be multiplied to get this expression. And the way I do that is I try and find a GCF, a greatest common factor. We have done that before. And I'm going to divide it out of both. So what is the GCF between 7b squared and negative 14? Well, first, between 7 and 14, what could I divide evenly out of both of those? The answer there is a 7. I can divide 7 out of both of these evenly. 7 divided by 7 is 1. Negative 14 divided by 17 is negative 2. So that's part 1. And part 2, what about the variables? What variables do they have in common? Well, they both have b's. This one has 2 b's, and that one has 1 b. So how many do they have in common? They each have 1 b in common. We covered this probably right after Christmas break, our winter break. We came back and we started doing factoring like this. So if I could divide a 7b out of both, what this is going to look like now we chose our GCF is 7b. So you write it like a distribution problem, 7b. I'm going to divide the green 7b out of both terms. So 7 divided by 7 is 1. B squared over b, subtract them, right? 2, so I have 1b left, right? This cancels out that. Then we have negative 14 divided by 7, that's negative 2, and then b divided by b cancels. All right, so we took 7b squared minus 14b and rewrote it. We factored it into 7b times the quantity b minus 2. These two, what I have in green here and what we started with, are the same. One is just factored. If I took 7b times the quantity b minus 2, if I distributed this, I would get this. Okay, so I'm really just taking an expression and writing it a different way. So, back to our problem. It was a little side journey here. Okay, so I rewrote 7b squared minus 14b as 7b and then b minus 2 in parentheses. Now, all that work wasn't for nothing. The reason I did that, okay, is because, like I said, we couldn't simplify anything the way this was written. But when we factored the bottom, the denominator, look what I have. I have a b minus 2 on top and a b minus 2 on bottom. Now, if they match, I can cancel them out. B minus 2 divided by b minus 2 is 1. So the reason we did that factoring was so that we can get those matching b minus 2's and we can cancel them out. So now our final answer, there's nothing left on top, so I'm just going to put a 1 there. And then what's left on bottom? A 7b. There's our final answer. So we took this big expression, we have b minus 2 over 7b squared minus 14b, and simplified it into 1 over 7b. These are the same. Okay, it's just a simplified version of the same thing. If I plugged in a variable for b, if I plugged in the variable 2, okay, I would get the same answer whether I plugged it into this one or this one. This is just the simplified version. All right, let's go to the next one. Okay, I can't do anything as it sits right now. I can't stress this enough. I cannot cross these off. If they are a part of a binomial or a trinomial like this, I cannot break these apart. The only way I could simplify this is by factoring one or both the numerator and the denominator independently. So let's factor. I think both of these are going to factor in this case. So let's start with the top. We have 42x plus 54. What could I divide out of both of those? I can divide, I think, 7. Is it 7? 6 times 7 is 42. 7, I don't know. 7 and 8, no. 6? 6. So I could divide a 6 out of both of these. Okay, when I divide 6, and only one of them has an x, this one is 42x, but since there's no x over here, I can't divide any variable out. They both have to have a variable. It's a greatest common factor. They don't have a variable in common. So so I put the 6 on the outside. Remember, it should look like a distribution problem when I'm done. 6 on the outside, it's going to be 7. 6 divided by 42 is 7. Just leave the x. Plus, and 6 divided by 54 is 9. So there's the factored version of the top. So I'm going to write it. 6, 7x plus 9. All right. And now let's jump to the bottom. Same thing, factor. I have 12x plus 18. What can I divide out of both? This one should be a little easier. How about another 6? So we have 6, and it's going to be 2x plus 3. I divided both by 6. 12 divided by 6 is 2, and I just drop down the x. And then 18 divided by 6 is 3. There's no x to drop down. So now my bottom is going to be 6. Let's see, 2x plus 3. Now again, I cannot break apart these binomials that are in the parentheses. I cannot I cannot go in here and cross off these x's. I cannot do that. I cannot simplify 3 over 9. You're going to want to. You can't. The only way we could simplify these parentheses is if they were perfect matches, and then I can cross them off. But they're not perfect matches, so I'm going to have to leave them. Those are going to be a part of my answer. What I can cross off, however, are these 6's out in front, right? 6 over 6. Those match. You can simplify these fractions. If it's a 6 over 6, that simplifies to 1. So we could just cross those off. If, for example, it was, and it's not, 6 over 3, we could still simplify that fraction just like we did in the beginning because they are not part of an expression. They're like outside the expression. That's why we factored out the 6 in both, so that I have something that I could possibly cross off or simplify. So our final answer is what's left is this. So I'm just going to rewrite it as the 7x plus 9. Once you're done, you could write it in parentheses or not. It's right either way. And then 2x plus 3. That's our answer. Okay. Seems kind of complicated, but it's at least simpler than what we started with. What we started with, we had bigger numbers. We had 42, 54, 12, and 8, and now we simplified the numbers a little bit. All right, so those are the two when we have binomials, we have how we have to factor. And then last, we have x marks the spot. They will be easier x marks the spots to start. Okay, so we'll do one here, we'll do one here. Okay, just to recall what x marks the spot is, the top number we have, so we have the a term, b, and the c term in standard form of a trinomial. So the top gets the c, the ceiling, remember, c goes on top. The basement, the b, goes on bottom. All right, so for the first one, the c is 12, and the b is 7. All right, and the game is I have to figure out which two numbers, okay, I have to put two numbers here, multiply to get the top, add to get the bottom. So multiply to get the top, add to the bottom. So what two numbers multiply to 12, but then add to 7? 3 times 4 gives me 12. 3 plus 4 gives me 7. So the answer, and I'm pretty much done here. Now I rewrite it. Remember how we write these. Okay, it's going to be two binomials. It's going to be x plus 3, x plus 4. Okay, and there you go. And you do the same thing for the other problem. Here's my x. The c goes on top. The b goes on bottom. So it multiplies to 24, adds to 11. Okay, and you could use your multiplication chart for that as well. So my magic numbers are 8 and 3, so I go back. X plus 8, x plus 3. Okay, the order doesn't matter as far as like the numbers. Like this 3 and this 8 could be on other sides. It does not matter. Okay, and then when you get here, if I have any matching, which you should, you cross them off. Do I have any matching binomials? Yes, I do. Match, match. X plus 3 on top and bottom. You can only cross off if they're top and bottom. If they're on the same line, you cannot cross them off. They have to be top to bottom. So x plus 3 and x plus 3 cancel. I'm left with an x plus 4 on top, x plus 8 on bottom. I said you could leave the parentheses, or if you want to take them off at the end, you can. Unless they're, well, I would just leave them in parentheses, honestly. That might be a little much. Oh, that's kind of a cool little box, but whatever. There you go. All right, so there it is. There's simplifying rational expressions by factoring. Okay, if you have any questions, send me any messages in Canvas, and I will see you after the weekend. Make sure you did the homework quiz already, and make sure you turn this in before 11 p.m. tonight finished. All right, good luck, and I'll talk to you later.